Morales and Google. Define hackathon, Morales and Google. Define and define hackathon, Morales and Google. Define and define hackathon, Morales and Google. Define and define hackathon, Morales and Google. 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 Morales and Google.
Greetings, developers and hackathon participants. Welcome to another Defining DeFi live stream event. We are here for a BNB Chain workshop on scaling Dapps with BNB Chain. And again, we have Vic joining us. Vic, welcome to the stage. All right, here we are. Yeah, sorry about that.
It's all right. Thank you. Great to be here. And thanks for everyone to joining us on Friday.
Real quick before we jump into it, I just want to do a quick recap of the things that we've updated on our webpage for our viewers today. I'm going to share my screen here real briefly, and then we'll dive into our workshop. All right. Are you guys able to see my screen there? Here we have, this is our Defining DeFi hackathon webpage. Now, the reason why I'm bringing this up is we've made some improvements to our prize breakdowns. Here is the breakdown for BNB Track, the host of our workshop today. And then the other sponsors are available here as well. We've also added details on bounties, so please do check that out. Registration is closed, but the submission form is now available. So if you're looking for details on what you'll be asked to submit, go ahead and check that out early. Lastly, I want to remind everybody that this is our mid-hackathon check-in weekend. What that means is everybody has received an email with a midway hackathon checkpoint form. Please complete this because this helps us to know where we have the greatest saturation of development in this event. And we can use that information to improve this event and future events. So thank you so much for filling that out. Everybody who completes this will receive a link to mint their own POAP. Proof of attendance in this hackathon. So if there are any questions on that, reach out to me or our community engineers in Discord. We're happy to help, and looking forward to getting a lot of responses on this over the weekend. There is a link in the announcement section for the hackathon in Discord too, if you need the link. All right, on that note, I'm going to hand it over to our host, Vic, to get started on our workshop.
Can you see my screen?
Yep. Adding to the screen right now, and we can see what you can see.
Cool. Okay, so today we are going to talk about scaling applications with BNB Chain. And we'll have it, overall, we want to describe a little bit about the benchmarking itself, how from your perspective you should be looking at benchmarking. Then we are going to compare some blockchains in terms of their performance, and then we'll get to the some of the features that BNB Chain provides to improve the scalability and performance of your applications. In the end, we'll discuss also our new program for the growth. So stay tuned, and we'll share all these details today. So when we talk about scalability, we need to understand that it, in the end, it relates to growth. So our goal is to build the infrastructure for mass adoption and accelerate user growth. In the end, your dApp will be dependent upon the number of users that you have. It doesn't matter if you have B2C as business to consumers or B2B, business to business. In the end, at some point you'll get to the issues with scalability. So in BNB Chain, we have a diverse ecosystem, and every application is different. Every application serves a little bit different niche, a little bit different domain. And from the blockchain perspective, as an infrastructure, it is very important to be able to scale to different use cases. Some use cases require a lot of daily active users. Others require a lot of transactions. So while these all applications run on the same blockchain, as an infrastructure builders, we are looking at the ecosystem as the whole to be able to identify the gaps where the improvement is needed. And you as the application builders, you will get to the same issues, but within your own community. So once you introduce your great idea to your community and start growing, a lot of people will come, and these are the good problems to solve, to be able to serve as much demand as possible and as many users as come. So let's discuss about, before actually going into some techniques for scaling the applications, let's discuss why do you need to scale and how do you need to scale. So, because before you understand your use case and before you understand your usage pattern, you won't be able to know how do you need to scale or whether you need to scale at all. Usually, projects rely on transactions per second, or TPS, and this is heavily used throughout the industry. And after working with a lot of projects, we identified that there is no single agreed way to benchmark the TPS. Most likely, the projects that show the TPS, and this relates both for your project, for your competitors. Sometimes you see different numbers and you be amazed, or sometimes you see, like, wonder how this is possible. And mostly this is possible because the measurement is of a simple value transfer. So essentially, when you transfer tokens from one wallet to another, this is the simplest interaction with the blockchain that you can do. And these are the ones that being measured. So they're extremely cheap. You can do a lot of them. And most importantly, they don't really reflect the real use case, the real usage patterns of the application. Even if you have some kind of decentralized lending protocol, you still have lending, borrowing, putting or adding more deposits, and so you have a variety of actions that can be done even within the DeFi space. And when you measure only the transfers, these produce big numbers, but it really doesn't reflect what is going to happen in the future. Even more crucial is that most of the measurements are done on the DevNets, which is like a cluster deployment on your own environment, and a little better when it is done on the testnet. Mostly never on the mainnet, only after the project is deployed and is very, very mature. Then sort of like the circumstances say that the measurements needs to be done on the mainnet, but mostly it is done on the DevNet, on the testnet. Also important factor of especially that is related to the new chains, on new protocols is that it has very low data visibility and observability, and meaning it is very difficult to prove what exactly is being measured and how. So this is also something to be aware of, that when the new protocol comes out and advertising great performance, this has to be taken with a grain of salt. And what is performance? So we discussed about transactions per second, but if we talk about like a broader sense of distributed networks, which blockchain is an example of such networks. So we have two different measurements of throughput and latency. And since throughput is measured in transactions per second and latency is measured per second, in seconds, some people think that throughput can be like deduced by load divided by latency. But it is not entirely correct. So if we get into what it is, so throughput measures the number of transactions executed during the specific time period. So essentially, if you get a limited window of measurement, you count how many transactions have been executed. And let's put the finality on and any other blockchain specific attributes aside. If we're talking about like a networking system, so how many transactions or packets have been processed. And latency, on the other hand, measures the time until the transaction is executed. So essentially, when the transaction has been put to queue, from that point, how much time goes until it is being executed. So we don't count how many of those are being executed, but how much like of this delay is being put by the network. So having these two measurements, you would think that it's a good graph to produce to put throughput or latency on the axis y and number of nodes on the axis axis x, and this would give you a nice linear graph with the more nodes you add, the better throughput you receive. You're excited and you say and you advertise both to your community and investors that you have a horizontal scale, an infinite scale. No matter what you give me, I can add more nodes, and my protocol or app will just cope with everything. But the reality is that the system, the networking system or distributed system, as we said, blockchain is such as an example of this category, have two different modes, so to speak. We have a long contention mode and high contention mode. Essentially, when you have a lot of users coming or a lot of traffic, it depends on your use case, then you have a high contention, and when the usage is low, then you have a low contention. The low contention is easy, is essentially whenever the transaction or the packet comes, it comes out directly. So it doesn't really, the latency is constant, defined by the protocol, and the throughput is varied essentially by the usage, by the demand. And as you have queue delay is zero because there is no really overload of the network, you only get the fixed minimum cost of to commit transactions. And this is an easy case. So if we look on the high contention, mode, it's the reverse, because the throughput is constant, defined by the here it's modeled by the architecture, and if your protocol can only cope with a number of specific transactions, then this is what it is, and the latency grows as adding more load to the system creates an infinite queues. So essentially, the network becomes too congested for even to process the transactions. And if we look at if we plot latency and throughput together, then you will see that these two modes can be like plotted in the L-shaped graph, where initially when there is low contention, then the throughput is irrelevant, and when it goes further, then it's the opposite. The latency is irrelevant. And naturally, when you measure something like this, or this is like in such environment, you need to think about where actually you would want to measure, at which under which conditions. Usually it's somewhere like here, like in the middle. So you the system is like average load, and you under different typical use cases. So that would give a somewhat correct measurement of the system. But how would you actually do it? So, because in the end, it also depends on the use case. That usually there are two methodologies to the measurement, and which is called request flow. In the open loop, there are infinite number of clients, and so from our perspective, this is like thousands of application servers. And you need to be able to provide or to simulate a high period, to have a periods of high and low load, because sometimes it's heavily loaded and sometimes it's they're like, depends on the time zone, whatever. It's a little bit different. So you need to be able to create this kind of distribution of arrival of the transactions, of the packets. Usually it's done through the Poisson distribution, which is usually is the one that measure that is simulating like earthquakes scenarios. So this kind of thing. So happens one in a while, and combining this together, this would give you some kind of like a representative collection of transactions. On the opposite side is the closed loop, where you have a limited number of outstanding requests at any given time, with a few blocking. In this case, it will be like a few blocking servers. This is very similar. For instance, if we say that the open loop is more like a L1 kind of thing, where you have an infinite number of clients to being able to connect, either as validators or some kind of other roles in the network. And closed loop is something similar to the L2 solutions, where you would usually have a more centralized network, but with later on some kind of mathematical proofing that would negate the centralization of their creation. In this case, in both cases, you still have to take into account a warm-up delays, because when you add a new server, either you do it through some kind of scalability solutions or by the cloud providers, or by actually adding servers to the network. There is a warm-up time to start the the container or to run some kind of batch logic there. And this is also needs to be taken into account, as this is something that affects the measurement very much. And also, usually when you have a simulated scenario, you typically load the transactions into the memory, and like to be able, so you like have some kind of like pre-generated data set of millions of transactions, and you would put it into the memory and then just run it. And while this is a good technique, this also affects that performance because it bypasses the network stack, meaning that these specific transactions have not originated from the distributed environment. It has come directly within this local machine. And this is something to take into account, either by adding some kind of error parameters, or actually at least sending them from a JSON machine. So that would be at least better. How do we measure better? So as we said, the difficulties are that latency and throughput are independent. Depends on the system. You're either in the constant latency system or in the constant throughput system. So this needs to be taken into account. And we also need to be able to see where is the limit of the system. As we said, at the limit, there is a maximum throughput, but latency is not so is meaningless. So to combine all of this, there is a name to this. It is called the service level objective, or SLO, and this is essentially the sort of like agreement that think of it as you're a data provider or some kind of service provider, and you're signing an agreement with your clients, and your clients are very suspicious and worry about whether your system will perform under stress or at all. And you would want with them, or they would want to define a minimal measurement of reliability, availability, something that you would expect from your cloud providers such as AWS and GCP to give you. So when you're doing this kind of comparison analysis of the services, you typically look at this kind of measurement, how much failure it can sustain, or how many nodes you can take down, what is the throughput, what is the latency, what is the availability and reliability. So essentially, you are combining these measures that are important to you and are relevant to your use case, and you measure the throughput under these different conditions. So you start with some kind of minimal use case, then you increase, and then you reach to some kind of maximum, and that would be your typical assessment of what would be your maximum load at this particular stage of your growth. And then you draw the horizontal line at the throughput and latency graph, such as shown here. So you see that each line is still like a L shape, as we saw before, but as we have a different number of nodes, naturally it will act differently. So you have these different lines, and then once you have this dots of intersection of this line with your functions, then you plot it on different graph, which would reflect somewhat averaged measurement under different conditions, and that is a very good measurement to show both to yourself and to your stakeholders, for them to understand what your system can actually perform. Given that, how do we approach scalability in the infrastructure level at the BNB chain? So during this year, we had several initiatives in our technical roadmap, and as the year is coming to an end, it will be a good place and time to discuss these initiatives and their value to the overall performance and the community. So we'll talk about different aspects of the roadmap from the technology perspective and specifically from the scaling perspective. And this is what we came to talk here. And before that, we would want to compare the blockchains as overall. So we looked at different measurements that we can do. So if we talk about blockchains as infrastructure providers, so what can we deduce given these measurements techniques that we saw? And one of these if we talk about EVM world, one of the important aspects of measuring the performance or throughput of the network is actually related to gas, and is called block gas cap. And why is this so important? Because eventually the EVM is built in such a way that each block is capped by the number of gas that all the transactions inside of it can be accumulated. So for instance, you have 100 transactions inside block. Each transaction has on average 1,000 gas. So in the end, you get 100,000 gas. And if you cap it by 90,000, for instance, then you wouldn't be able to put these transactions into the block, even though your network is under light condition, because under the protocol you just cannot put so much gas that is inside each block. And the gas is defined by the operations. So we know, like, it depends on the operations that are performed by the smart contracts. So different transactions have different smart contracts involved with the execution, but in the end, this all come up and sum up to the block gas limit. And why is this important? Because if we look at the EVM comparable blockchains, we can see an interesting phenomenon where it's very diverse. So for instance, for the Ethereum mainnet, the gas cap is 12 million, 12 and a half. In the Polygon network, it's 30 million, so twice is that. So the Polygon should be theoretically twice as capable as Ethereum mainnet. But what is interesting that BNB Chain has a gas limit of 120, and this is not accidental. This is something that has been done as part of this year improvement to ensure that we have faster transactions, low cost, and extra capability. So this involves to extra capability, because it doesn't matter how fast you are, if you're still not capable to put these transactions into the block, it won't matter. So during this year, BNB Chain has increased the overall block gas limit to 120, and plans to increase it to 150 by the end of the year. And that would mean that theoretically, under the same conditions, like vanilla blockchain, vanilla Ethereum blockchain, you can put 4 times more transactions into block, and 10 times then compared to Polygon, and 10 times then compared to Ethereum. And this is has a very big impact on the overall performance. If we look at the Avalanche, it has a little bit different block production mechanism than other proof of stake chains, and so it has this a high variance between the average load and the maximum load. But what is interesting that sustaining maximum throughput raises the fees exponentially. So while it is capable to perform at the max throughput, the fees would make it not very economical, and this sort of like negates the high throughput at for a long period of time. And the other aspect of comparison of the EVM chains is what is called London hard fork, which was introduced last year. And as part of its, it has introduced a lot of features around block creation and mining. But one of the features was to under this EIP is that blockchains are bounded by the twice of the throughput, so meaning that the average throughput of the network. So if we increase the demand for the network can only perform twice as good. So this is why if we look at the graph of the measurement, you see that Ethereum, Polygon, and Cello are like divided between two sides, between the average and the maximum load, and this is like exactly twice. So you have like this Polygon, and then you have twice as much. And as we said, Avalanche is a little bit different. So the average load is somewhat comparable to Polygon, but the maximum is a lot higher. We can say that somewhat comparable to BNB Chain. And why BNB Chain doesn't have this like hollow block is because BNB Chain doesn't follow the London hard fork, so it doesn't have this constraint, and it can perform at the maximum throughput for a long period of time. As we said before, transactions per second usually measured in terms of token transfers. So if following this, if we take token transfers and go to the main trading platform on the networks, on the Polygon, Ethereum, Avalanche, and BNB Chain. So we go to QuickSwap, Uniswap, TradersJour, and PancakeSwap. We can measure this performance of this network somewhat, because we assume that, of course, that as these platforms, what they do, the essence of their work on operation is token transfers. This is a good representation of the mainnet use case and measurement, because these are the mainnet highly popular platforms. So while they have, as I said before, more use cases in terms of not only token transfers, it is, if we are comparing similar products, we can say that on average they would have still the same type of transactions. So if QuickSwap has some kind of loans and deposits and whatnot. And then Uniswap would have the same, because these are comparable products in the free market, and they usually would have the same feature set just to sustain their value proposition to the users. So if we measure these platforms on the network, on the mainnet, then we would get somewhat a representation of how many trades can be done per second, because what we can do is then we can measure the number of trades, somehow summarize it, and reduce naturally the noise, and we could get the average result. And doing so, and plotting on the graph, we can see similar results to what we had under the gas limit, which was somewhat hypothetical. Here we have empiric measurements which reassess the same statements that we have Ethereum, then we have Avalanche, that is again due to its intrinsic build, it has like this average and maximum are somewhat different, and we have Polygon and then BNB Chain. What you can notice in both cases, BNB Chain leads far ahead ahead of other blockchains. And if we want to take also, okay, for instance, but what about Avalanche? So what do we say about that? So as I said, since Avalanche is built a little bit different, it has a high variation of the gas price, and this naturally this is a public data, so you can look at it as a general average gas price chart, which can be taken at the BSS scan or in this case in Snowtrace. And if you take comparable time, then what you essentially would see that like for the last year at least, this will take this we can disregard because the network was just launched 2 years ago. So let's take, for instance, last year, and this is somewhat representative, and we take the same period of time on the Avalanche network, then you would see that the gas price in the Avalanche ecosystem varies a lot, just the variability of the gas price. And as John von Neumann said, all state processes we should predict, meaning that from your perspective as either the already existing or the future business owner, you want to have your cost to be predictable so that you could predict your cash flows, and so that you can predict your cash burn, which is most important for the companies. These metrics essentially saying how much money, how much cash do I have in hand, and how much cash do I have left until I hit zero in my account. So having spikes like 3 times in the gas prices within the time frame of even like 1 or 2 months, this can differentiate between a business that had went out of business and the one that had not, because having received a bill, since it's blockchain, you are paying on demand, so you don't really receive a bill. But like if you had, so like for today, for the current months, your bill would be triple of your previous months. This is something that you cannot predict, and you would have to cut your workforce and maybe even close the business, because you cannot run the business where your costs vary a multiple of times, like from months to months. This is very this is not very friendly environment for the business. Let's go to the next improvement that we went that we undergone through this year. It's a parallel transaction, and when you hear the word parallel transaction, you would usually think about Solana environment, as Solana was the first one who introduced parallel execution model, and this was sort of like the flagship blockchain in this domain. And what BNB Chain has introduced this year is something very similar, not to the point we'll discuss later, but is very, very comparable, and this would produce very interesting results. Why will? Because it's just being finalized. The last commit was actually the pull request merge was done a few days ago. So this is something that is being developed and even released and tested as we speak, literally, and is going to be released to public within a near future. So let's discuss what it actually is. So when we talk about the EVM infrastructure, a little bit on the how it really works. So this is very typical to the Java virtual machine. So we have ROM or some kind of storage where you store your code to be executable. You have a storage, you have a memory like operational memory, you have a stack to go through the line by line code, and gas we don't care about, and we have essentially a instruction pointer, program counter, and the CPU itself, like the execution model. And the issue with the EVM, like as an environment, is that like any other, is that the account storage can change by if you allow multiprocessing or concurrency, then two different processes, or in our case, two different smart contracts, when executed in parallel, can change the same account state. So that would essentially result that if we're talking about the DeFi space, then one smart contract would want to add funds to a particular account, and the other one, or deduct would be better, to deduct funds from a particular account, and the other one wants to do the same. Then not having enough funds would result a negative balance, which is something that we don't want to occur in the blockchain environment, at least in its base form. And the existing EVM execution engine does not allow concurrent operations. So essentially, transactions are executed one by one, and if a state is changed by one transaction, and so it must be reflected in the another transaction. And this is fine for the introduction, but already we have the EVM world exists for over 5 years already, and on the BNB chain community, it was decided that it is enough, and we need to progress into the future. So why is concurrency even possible? So similarly to Solana environment, where they understood that it's very unlikely that the two different smart contracts in the overall ecosystem would interact with the same account, then there is a place for concurrency. And not even so, they architected the system in a way that you need to provide the accounts ahead of time, and then the engine knows which accounts are being changed by the smart contract, and then this whole thing can be orchestrated into one execution engine. On the EVM world, naturally, we cannot do this. We cannot change the whole thing because we want still to be EVM compatible. So how can transactions be run concurrently on the EVM? So we cannot change the existing smart contracts, and we cannot change the existing clients. So everything needs to remain the same, because we cannot just say, let's do it like Solana, and from now on, every smart contract needs to add the accounts that they interact with. This is something that just would not work, because you have to rewrite all the smart contracts that already been done. We also cannot add new opcodes, so to speak, like new operations to the Solidity language, just to enable this kind of interaction. It has to be optional, because to remain decentralized, we still want the same validators or new validators to come with the same hardware restrictions. We don't want to enable or to cause the situation where the existing validators would have to upgrade their hardware just because we want to improve the performance of the system. So essentially, everything needs to be the same from all the parties, and it has to be simple. It has to be simple to remain reliable and to remove errors. Because if we make it overcomplicated, then it would be definitely a recipe for disaster. It also has to be finally limited overhead, because as usually in the when we talk about concurrency theory and multi-threaded environment, the more concurrency you introduce to the system, the more overhead you have, just because, for instance, you need to combine everything together, you need to split the state. Eventually, CPU is being executed by the CPU, and this particular chip, during execution, would have to switch context, load different memory, load different state. So there is an undeniable effect on the performance only by introducing concurrency. So we need to make sure that the benefit introduced by the concurrency needs to be much higher than the effect of it that it creates on the system. And so BNB Chain has introduced parallel transaction execution, and the first attempt through it was to essentially to create a concurrent execution flow. So we would have, as I said, so we cannot change the way the EVM works. So if you make a concurrency possible, then conflict can be created, because two different smart contracts or transactions can touch or change the state of of the same account, and this cannot be predetermined before, because if we execute the same code, we just cannot know what the smart contract is going to do. So the idea is that we allow the transactions to run in parallel, but they would need to wait until one finishes, then the other would start. We would check for conflicts. if there are conflicts exist, those would be the conflicting transaction would have to reload the state, rerun, and the others will have to wait, just not to pile up on the conflicts. If, on the other hand, transactions run without conflicts, that is the assumption that in the mainnet environment, a lot of smart contracts touch different accounts, and then it wouldn't be even an issue. So essentially, these transactions can run totally in parallel and committed one after another. The results were promising, and the introduction of the parallel transaction execution engine has increased the throughput by 8%, and with a minimal overhead of 250 microseconds per block, and only 10 megabytes of RAM for the validator. So the initial steps were good. So then we decided to increase it a little bit and sort of like create a parallel EVM 2.0. And the idea of it would be to not having to wait. So there will be no waiting streaming pipeline. And so we won't have to wait until one to another. We can run this in parallel. And the way it was done, it was the conflict detection mechanism was rewritten entirely and introducing something like a dirty state, and to enable the transactions actually to run in parallel and then committing one after another. That would gain another 50% improvement. And this is great. And this is something that if we run two versions of like the first one and the second one on the same machines for 50 hours, we would have 40% less conflicts, and we would have up to 50% less block process cost, which is like execution, validation, committing, anything related to the creating of the block. And the difference is, this is what this is what we started our workshop with, is you cannot just run one scenario. You have different block creation patterns, you have different types of transactions, and to enable this kind of measurement on the infrastructure level, you need to think about different states. So usually what it's being done is you take a snapshot of the real transactions, and then you rerun it as if being new on the two different variations of the system, and that's what has been done and ran for 50 hours. So this is something that has been like, if we take it like it's 2 days, so would come across different time zones and would be somewhat representative of the actual environment of what is going to happen. So this is something that is being introduced as we speak, as I said, and this improvement would be on the core level of BNB Chain, so there will be no need to do anything, and you would just gain this improvement even on top of the already highly performant blockchain. However, we do want to move more. We do want to give you more to the community, to the users, and to the projects. And so while the previous improvement improves the throughput of the system, it doesn't really affect the gas prices. So even if you put like a little bit more transactions, we saw the difference like 10-20%. It's definitely considerable, but it won't affect the tokenomics of the BNB token and the overall blockchain to the point that we want to, or at least our high growth partners want to. During this year, initiative in the ZK rollup was started, and we are now recently, last month, it has been open sourced, ZK BNB, and it is now being released to the testnet. So as I said, as we speak, the improvements are always coming to the BNB chain. So we should see the ZK BNB within several weeks on the testnet environment, and the mainnet is soon to come after that. So what is it? What is it, ZK BNB? And for those who are not familiar with the terms, so let's take a step back to understand how is really ZK BNB, which is a flavor of ZK rollup, which is a flavor of layer 2 solution. So what is layer 2 solution, and why are these supposed to reduce the gas fees? So layer 1 is something that we all know and use. This is our standard-based consensus layer. So this is Ethereum network. This is the BNB chain, and this is something that is sort of like all the transactions are currently settled. This is the current situation. Depends on the network, depends on the conditions. So we can say that it's like on the BNB chain, it's plus minus 40 transactions per second, which is decent. But for if we want to support a really high growth projects, this is not enough. And by far, this is something that no concurrency can improve. And so throughout the years, different ideas have been introduced, and as one of them that has accumulated enough traction was to build a layer 2 solution on top of layer 1. And the idea behind it that the layer 1 doesn't know that the layer 2 exists. It's built, the L2 is built on top of it, and it would be just it would be built with the same building blocks, and so no changes is required. It will settle on the L1. So from the security perspective and the protocol perspective of the base blockchain, there will be no changes in whatsoever, and the existing also protocols and applications that run and have some kind of interactions with the blockchain wouldn't know the difference from how the block was produced. And the main purpose of it is that it can support a much higher transactions per second. So if we talk about even like token transfer, so comparing apples to apples, on L1 we are able to make 40 transfers per second, and on L2, for instance, we can make 4,000, which is like a 100-fold improvement of the performance. And this is naturally a game-changing improvement for the high growth applications that require interactions, continuous interactions, real-time interactions. And this is something that once implemented and introduced to the masses, to the community, could change the Web3 ecosystem entirely, and introducing more and more use cases, both in the DeFi space, in the gaming space, in the social, all the domains that require continuous interactions and real-time user experience. And what is interesting is that layer 2 solutions are already being used by Bitcoin or Zcash. So this is not something new. This is this has been used in one way or another by the industry already a few years. And on the BNB chain, we decided that given that more and more projects are being added to the system, that this is the time to add this layer 2 scalability solution to support these projects. If we look at the BNB architecture as a whole, so we have in the middle, like we have a BNB smart chain, which executes the smart contracts. We have a beacon chain that related to the governance aspects of the system. And to the side, so to speak, we have a scaling solution. And this is where side chains called, and you can put as many chains as you want. And zkBNB is only one of the introduced scaling solutions. And naturally, if you can either have more. So if as these are all EVM compatible, we live in the EVM compatible world, so to speak. So we can also put more ZK rollups or different flavors, and also other solutions on top of our layer 1, and everything will still work, but in much more scalable way. So the idea is that so what does zkBNB provide? So it provides superior performance with the same security. And so what it does is essentially it's bundling up transactions from the sidechain, building its offline, and then putting everything together. The whole thing is secured by the cryptography, which called SNARK. We won't get into the details. And the idea is that you don't need to monitor everything, as everything defined by the mathematics, and can be proved mathematically, so you don't need validators or anything like this. And the data itself is stored, the transaction data is stored on the BNB chain. So, and everything else that is not needed are being stored on the layer 2. And this is the best suited for the Web3 projects, as what you get is essentially a dedicated use cases, a dedicated solution for the use cases such as DeFi, gaming, and social. And as I said, it's super fast, up to 10,000 TPS, and with, most importantly, instant finality, as this is mathematically proved. You don't need actually to wait for something to be valid, because it's already valid once it's created. Because how it works, it's as it stores a lot of data away from the blockchain, and storage is the most expensive thing on the blockchain. You get a much lower gas fee. So this is how the gas fee, lowered gas fee, is produced. You just don't store as much information as you would in the conventional blockchain creation. So if we talk about use cases, it provides an instant AMM swap, and using liquidity pools, and also NFT marketplace for crypto collectibles, and out-of-the-box API services. To make it more user-friendly also, it also has a built-in naming service for human-readable names mapped into public keys. So as I said, this has been open sourced 2 months ago, and is currently being put into the network, into the testnet. You still can use it in terms of you can go just to the GitHub and just clone it, download it, run it on your locally, and you can already use it for as part of this workshop or as part of this initiative. and this would still count, and it would be great to see use cases like this. For the end, I would like to tell about that in 2 days we are concluding the BNB Chain Innovation Incubator application period. So you have still 2 days to look at it and apply. And what it provides is essentially it's only for Europe, but more are being rolled out. So if you are in Europe, this is something that for you to definitely to look to, and we would love to see you register. And for other time zones, just stay tuned, and we would get more of such initiatives in your time zone as well. As usual, to the end, I invite you to contribute to our building community on different languages, on different platforms, and we're all happy to see you and build the BNB world together. Back to you.
Wonderful. Wow, what a wealth of information on scaling our applications. Since we did take quite a bit of time here, I'm going to go ahead and move question and answer over to GatherTown. So go ahead and click the link in the description below. Get your profile set up with your characters so that you can join us there. The space is very straightforward. If you're joining us for the first time, you just walk around the same way you would in any virtual environment. It's two-dimensional. And if you're in close proximity to somebody, you have the option to turn on your camera and talk with them. Of course, you can shut that stuff off too and just join us to listen in on what we're talking about. All of that's okay. We're just looking forward to seeing as many people there as possible. Have a great Friday. We're going to be back next week with even more workshops. Vic is here with us again next Friday. And thank you, sir. And thank you to BNB Chain for a wonderful workshop today. Looking forward to talking more with you guys soon.
Thank you too, guys. Thank you for coming.